Okay, so we're looking at this position versus time question. So the second question on the sheet, hopefully you gave this one a try before clicking on this video. And now we're going to give it a quick look together. So what we have here is position versus time. And this looks a heck of a lot like one of those polynomial, this second order polynomial, this quadratic, where we're related to our horizontal axis squared. This x squared, in this case though, time is on our x-axis. So hopefully what you're looking at here is we're saying, well, and I'm going to, confusingly, I'm going to call our position x, I'm going to call time t, just because that's our convention, but just remember this is on our vertical axis and this is on our horizontal axis. So just kind of keep that in mind. So what we would do traditionally if we wanted to express this relationship is we'd say, well, this looks a lot like a y is related to an x squared graph. In this case, though, instead of y, we're going to use x because that's our variable on our vertical axis. And we'd say that is related to some sort of factor. I'm going to call it a, some sort of constant, times t squared. So I have this relationship, but again, just like last time, I do not have an ability to really easily come in here and be like, oh, I see what my a value is. That's really hard to calculate. That is a hard number to find. So now I have a reason to figure out why do I want to linearize this. So I say, well, this looks a lot like a y equals a times t squared. So if I wanted to make this linear, I could graph x equals a times t, some sort of other factor. So I'm just going to write my factor as the capital letter of the one that I want to be graphing. There's no really like convention for doing this. I just think it's easier, so it keeps us like, hey, this is a special t. This is not our normal t. It's kind of a big one. It's a special one. So there's really no convention for that, but that's just what I like to do. So I can say, okay, well, x equals a times t squared. If we graph x equals a times t, we know that that'll be linear. So let's make t squared equal to our capital T. So t squared is equal to our capital T. So time squared is our variable on our x-axis, on our horizontal axis. So let's go back to Google Sheets, come over here, and say, well, before we had position and time, now I want position and time squared. So instead of graphing time, I graph time squared. Second squared. And again, I can do like what I did before, where instead of doing each calculation, I can say this is equal to time. So we can either say to the second, or we can just do time times time. So that will calculate time squared for me. Pull that down, then we're good to go. I'm just going to copy and paste this because Google kind of likes it when you have your x-axis and then your y-axis right next to each other when you want to insert a chart. We go to Insert, Chart. And there we go. We have a nice linear relationship between them. Then I can come over here to Customize. I go to Series. I can click on the box that says Trendline. And then I can say Label. Give me a equation with this label on it. This did not force me through 0, but that's okay. It doesn't really matter. Our y-intercept is so low that it doesn't super matter. But so then what we say is, oh, well, we have this relationship, x equals 3 times t squared plus this really low number. Our y-intercept is so low that we're not even going to worry about it. But so let me just grab this really quick. Bring it back into OneNote. Okay, so we can say our relationship for our graph is position x equals 3 times t squared. All right, so you see that's our equation that they gave us. And again, we're saying this is so low. 3 times 10 to the negative 15th, or 4 times 10 to the negative 15th is so low, it's pretty much 0. So you can say, okay, let's get rid of all that. Okay, so we can say then, okay, or not t squared, I'm so sorry, t. So x is equal to 3 times t, where we said t was our variable on our horizontal axis. So x equals 3 times big T. And now what I can do is replace that, substitute back in, x equals 3t squared. So again, if I look at this, I can say, well, now this linear graph is super helpful. This linear graph is super useful to me because I can look at my slope. I can calculate the slope based on my graph, based on my line of best fit. I can calculate it and figure out how x is related to my variable on our horizontal axis. So now we can do that super easily, and we have a nice linearized equation that we can graph. We can figure out the growth factor between my vertical axis and my horizontal axis. So hopefully that one was okay. Then we have one more. I'll kind of make a key on that one, but I want you to try it out on your own.